So we've talked about ways to describe patterns. So here's our pattern. So the first way we talked about using words. So first we look at the pattern. So there's in the first figure, 4 items, second figure, 6 items, third figure, 8 items. So our pattern in this could be that this increases by 2 each time. So it continuously increases by 2. So figure number 4 would be 10 pineapples. Figure number 5 would be 12 pineapples. So it's just increased by 2 each time. So that's with words. Next we talk about doing a table. So figure 1, we have 4. Figure 2, we have 6. Figure 3, we have 8. Figure 4, we can continue because we're increasing by 2. We have 10 here. Now we've also talked about how on this table we can back up a step and do the 0 row, which is important for us to do for the next thing we're going to talk about. So if it's increasing by 2, I just back up 2 from 4, and this one would be 2. So in the 0 figure, it would have 2. All right, now we're going to talk about the third way about looking at this relationship that this pattern has. And when we make it into a table, there's 2 sets of numbers. So we've got the left side, or what we call the X, and then we have the right side, which we call the Y. Now you will remember too, there's the thing that you see when in younger grades, lower grades, where you'll do the input side, and this is the output side, meaning I plug this number into an expression, and this is the answer that is output or calculated. Okay, so that's what we're talking about here. Now, that expression that we're often given when we don't have these answers is what we're going to try and figure out today. So that relationship between this and this can create an expression. So this video is to introduce the amazing expression builder. Yeah, look at that. How's that for a very cinematographic? Nope, don't know how to say that. What a sweet way to introduce this. So here's our expression builder. Now, first, when you first look at this, it looks a little crazy. So this is the amazing expression builder. The amazing expression builder. So we have y equals positive or negative, blank, variable, so n, plus or minus something. Now how do we get these? That's the part, how do we fill in the blanks to fill in our expression. So here's what it is. It's quite simple. Once you have your table made, so you have to figure out what the change in the y is. So we always show that on our tables here. So the change in the y on this one is adding 2. So circle that and put a 2 in there. So this one goes, that is our numerical coefficient. The change in the y is our numerical coefficient. Now how do we figure out this, or the constant? That's why we need the 0 row. So whatever the value of y is in the 0 row, that is our constant. So this is a positive 2, so then it's plus 2. So the expression that works with this relationship here is 2n plus 2. 2n plus 2. Now, it's fine and dandy that I say that, but there's a way that we can prove that it actually works. So we'll take that expression down here. Let me make sure my paper's on. 2n plus 2. And we're going to substitute in, and we're going to input some values from the x side, or the n. And then we're going to see what the output is to see if it matches. So first we'll put the 1. So we have 2 times 1 plus 2. So 2 times 1 is 2 plus 2 equals 4. Hey, it checks, that is correct. Let's try with the 2. 2 times 2 plus 2. 2 times 2 is 4, plus 2 is 6. Correct. Okay, so this expression works for this pattern. Let's try another one. So here's my pattern of cars. Remember, this is always figure 1. Figure 1 has 2 cars. Second figure, 2, 4, 5 cars. Third figure, 4, 6, 8 cars. So we can see on this pattern here, the change in the y is we're increasing by 3. So for my 0 row, back up 3 from this, I have a negative 1. And I'll just throw in the 4th row here, 8 plus 3 is 11. Okay, so now we have my y value at 0, and then I know my change. So I can put these in. So again, this is my numerical coefficient, so a positive 3. And then my constant is this value here. So subtract 1. So the expression builder shows us that the expression that goes with this pattern is 3n minus 1. So let's plug in some here and do our checks to make sure if it's working. So let's do the 1. So 3 times 1, subtract 1. 3 times 1 is 3, subtract 1 equals 2. Check. Let's jump down to this one. 3 times 3 is 9, minus 1, 8. Check. 3 times 4 minus 1. 3 times 4 is 12, minus 1 is 11. Hey, that one works too. Okay, so this is the correct expression for this pattern. We got 2 more to try here. So here's our pattern over here. These are avocados, might be hard to see. First figure, there's 4. There's 4 and 4, so this one's 8, and then this one's 12. So figure 1 was 4, then 8, then 12. So this is 0, and this is 4, so we're increasing by 4. So I'm going to back up on this one. That'll put me at 0. Here will put me at 16. So again, numerical coefficient. So into my expression builder, the change in the y goes first. And then this is the value of y when x is 0. So it's a 0. So this part I will do, I just put that in there, then I cross it out because we don't need to add or subtract 0 from something. So the expression builder gives us the expression of 4n for the relationship here. So again, we can try that by substituting the numbers to see if we get the output. So for the 1, 4 times 1 is 4, correct. 4 times 2 is 8, correct. 4 times 3 is 12, another one's correct. So this is the correct 4n. Sorry, I'm going to put an n there. Okay, so 4n is the expression that describes the relationship here. All right, one last one. So there's 3 in this one. I see there's 6 here and there's 9 here. So 3, 6, 9, we need our 0 row. We're increasing by 3, so we're going to decrease by 3. So that's back to 0. And sure, we'll go with 4, so it's a 12. Okay, again, numerical coefficient, so positive 3. And our value of y when x is at 0, okay, is 0. So then this is just, again, we cross that one out. So my expression for this one, the expression builder tells me that it's 3n. Let's check it out. Let's do the 2. 3 times 2 is 6. Nailed it. 3 times 3 is 9. Nailed it. 3 times 4 is 12. Nailed it. So this is 3n. So that's the expression that goes with this pattern. So that's how you use the expression builder.